Hello, everybody. I just wanted to take a couple minutes and walk through this formula sheet that you get to use on your Topic 9 test, just to give you some reminders about it so you know what you're looking at for the test. All right, so parabolas can be vertical or horizontal. A vertical parabola is one that opens up or opens down. A horizontal parabola could open to the left, it could open to the right. When we have these basic equations, so a y equals parabola would be vertical, and the x equals parabola is horizontal. If you notice, this equation is much more basic than this one. So our basic one we use when we know that our vertex is at the origin, is at 0, 0. So this vertex is at the origin, this vertex is at the origin. Every parabola has let's say we're looking at one that opens up. It has a focus that is, we can just kind of say here's our vertex. We can say it's inside the parabola. It has a directrix the same distance away on the other side. That's our directrix. If you have your vertex and your focus, the distance between these two is what that C value is. So from here to here, we'll change colors from here to here, that's what your C is. And if you notice, our equation uses a C. So often what we'll do is we might have some pieces of information about a parabola. We can sketch it out and actually count to see how far away these are. Your C value will be negative if your parabola is opening down or if your parabola is opening to the left. These equations that obviously look a little bit more complicated, this is what we call vertex form for parabolas. So it still has the 1 over 4c. C is still how far away the focus is from the vertex. This could be positive or negative. But we have these added h and k. Those are that's how you find your vertex. So our vertex now, this number goes here. But it's going to be, if it's inside parentheses, it's going to be tricky. So if you notice in these parentheses was an x, so this number is the x coordinate of your vertex. It looks like a negative h, so it would be a positive h. This number on the end is the y coordinate of your vertex. All right, now this one over here, when you have a horizontal parabola, notice that inside the parentheses is the y, where over here it was the x. So what that means is that in our vertex, this number is a y value. And it's going to be tricky in the same way that x is. If that is a negative k, it would be a positive k. And then this number on the end is the x coordinate of your vertex. So just be careful about that. If you have a horizontal parabola that starts out with x equals, we've got the y inside the parentheses. Then this is a y coordinate for the vertex, and this on the end is the x, kind of backwards of where they are over there. All right, so that is your parabolas. Circles, we have two equations for circles. This one that's pretty basic is when the center of your circle is at the origin, 0, 0. As soon as we move that center around, then the equation will look more like this one. We have an x minus h, a y minus k. So the center of this circle would be not a negative h, but a positive h, and not a negative k, but a positive k. And then remember, whatever the number is here is your radius squared. So just for example, let's say we had an equation of a circle that was equal to 49. Well, 49 is not the radius. 49 is your radius squared. So our radius would actually be a 7. If you guys graph circles, remember you start by plotting the center. It'll either be at the origin or somewhere else. And then, so let's say, use this color. If that's the center, then whatever your radius is, you can go that many units in each direction, up, down, left, or right, and then that's how we're going to sketch in a circle, like that. All right, your ellipses. An ellipse equation is equal to 1, and it has addition between the two terms. Equal to 1, addition. A horizontal major axis, this ellipse will horizontally will be the longer part. That's the longer axis. A vertical major axis is going to look more vertical like this one. The thing we need to remember with an ellipse is that your a squared is the biggest number. What I mean by that is you will have an equation of an ellipse. You want to look at this number and this number. If the number is bigger here, then you've got a horizontal ellipse. If the number is bigger over here, you're looking at a vertical ellipse. When you guys graph an ellipse, let me just throw this on here and here. Here's our center. On the major axis, from here to here, that is A units. From here to here, that's also A units long. Your B value will tell us on our minor axis. So from there to there is B units, and from here to here is B units. Now, if you have a vertical major axis, so more like a vertical ellipse, now our A value is vertical. So whatever A is, that would be our A value up here and down here. Where that helps us is if you know that your A value is 3, then from the center of your ellipse, you can just count up 3, plot a vertex, count down 3, plot a vertex. Also, when you count out your A value, this is a vertex and this is a vertex on the major axis over here, a vertex and a vertex. A covertex is on the minor axis. So that would be a covertex and this would be a covertex over here. All right, but let me get back to, we put in our A value. So on the minor axis, from here to here, that's our B value, and from here to here, that's our B value. So when you're looking at an equation of an ellipse, you can figure out, all right, what's your A, what's your B, and kind of work through how those would graph. Why do we have a Pythagorean relation here? That's because sometimes, well, actually, if you're graphing an ellipse, you need to know where the foci are. So in an ellipse, I'm going to draw one more, a little bit bigger. So here's a horizontal ellipse. This one's centered at the origin. So on the major axis, which is the horizontal axis, you're going to have a focus on one side and a focus on the other side. So the C value is how far away the focus is from the center of your ellipse. That's where the C value is. And you can find the C value using this Pythagorean relation. If you know your A and your B from the equation, plug in A squared, plug in B squared, you can solve for C to see where the foci would be. All right, lastly, we have hyperbolas. Hyperbolas, what you want to notice is you have those same looking fractions as an ellipse. However, a hyperbola will have subtraction. And it will equal 1 like an ellipse does, but it has subtraction equal to 1. Hyperbola you can have a horizontal hyperbola or a vertical one. What a horizontal one will look like, it would mean that your vertex is on the horizontal axis and it will open horizontally like this. Now, your A value is the distance from the center to the vertex. That's what our A value is. A hyperbola also has a focus inside each curve on the same axis. You guys will have a focus in both directions. Your C value will tell you how far away the focus is from the center. And we only worked with hyperbolas that were centered around the origin. So we only have to worry about the origin. So that's our C value. So if you are graphing a hyperbola, you would want to first determine if it's vertical or horizontal. Oh, one thing I did not mention. In an ellipse, your a squared is the biggest number. We wrote that above. In a hyperbola, the a squared is always in the first fraction. It's always that number. It could be underneath an x squared, it could be underneath a y squared. If you're a squared, this won't always be the bigger number. A could be smaller than b, but it is always in the first fraction. If your a squared is below the x squared, which is a horizontal axis, that's when you have a horizontal parabola. If your a squared is below the y squared, y is a vertical axis, that's when your hyperbola is vertical. Okay, now if you have your a squared and b squared and you have to figure out where each focus is, you can use your Pythagorean relation to find your c value. Lastly, real quick, let me just sketch what a vertical transverse or a vertical hyperbola is. That means that your vertex will go on the vertical axis. So you could have a vertex here, a vertex here. These will open, one will open up, one will open down. The a value is a similar idea, from the center or the origin to the vertex, that's a units long in both directions. The focus will be on the same axis as the vertex. It'll look like it's inside these curves. So we have a focus there and a focus there. And the focus is c units away from the center in both directions. So if you can figure out what your c value is from your Pythagorean relation, then you can go to your center and just count that many units. In a vertical hyperbola, you would count that many units above and that many units below to plot each focus. All right, there are some friendly reminders for the formula sheet. You guys will be given a formula sheet for the test, but it will have no writing on it. So the more that you familiarize yourself with this, then you'll recognize what you're looking at during the test.